for the last talk, we heard a great talk about how we can reliably generate a lot of data, and now I'm trying to tell you there might be a way that you can manage your data very easily. What is Signac? And so it's a Python-based data management software, and I will talk later about how it actually works. And it's completely open source, and it's very easy to install on Conda pip. So if you can do it on your own computer, you can install it on like a high-performance software. And there's also the documentation. So you can see there's like very good tutorials, like papers and like videos on how you can use it. The developers, they have hosted workshops for teaching people how to use it. So like that's not what I'm going to do here. I'm more just kind of trying to give you like a snippet of how this can be useful, and if you want to use it, like I'm very happy to talk to you about it, and then yeah. But this is kind of what we want to do, and you can already see that if we were to simulate this hand here that has like thousands of particles, and then we need to know the position of every one of them, and then we need to design interactions, and then we need to change the interactions. Every time you change interaction, it's something completely different. And so even like from this illustration is already a problem. So what we do in reality is like, and this is kind of like that movie, what we want to, this is like what people can do this day. So these are all these different particles that people can make in experiments. And they all have very amazing like shapes, features. And one thing you will notice here is like we can tune all these parameters continuously. So if you really want to do a large computational study, that you can divide as fine as your parameter space as possible. So you can do like a grid of 10 different parameters. You can do 100, you can do a million. Like, just like, it's really like the limitation is your imagination here. And so in that way, we can really generate a lot of data, and that provides a problem. And for every shape listed there, they at least ran like 20 different simulations or even more. The data is there, but every time when someone else wants to access that data, it's like very hard because how people store the data really depended on how their naming convention, and sometimes it doesn't have all the information you need, and then also it's a different people who are already graduated, so we don't even have anyone to ask. So it was a nightmare. We need to store a lot of data and metadata. So a lot of the metadata is like kind of at the initial setup of our simulation. So we need to know how many particles is in the box, like how many grapes you're putting in your Tupperware. And then we need to know like how the particles are interacting with each other and all sorts of different things. So you can imagine before you might just like put all this metadata on your file name, and you have a very long file name. And sometimes in this round, you saw this parameter was not important, so that was not a part of the file name. And later, you need to add that. Yeah, it was a nightmare. And regular expressions can only help you to so far. And then, of course, we also have data. So a lot of times the data what we have is like we run a very long simulation, and then we just have like the positions of every particle that is like for many, many different frames. So we get that data, and then we need to do like post-processing of that data. And a lot of times then we need to draw a figure of some properties we measure from that data based on the metadata we have. So you can imagine that. So metadata here is as important, sometimes even more important than data. Like we need both of them to make our research work. And sometimes we rely on the metadata to be able to, for other people to replicate our result. And being able to replicate results is very important in when you're doing computer simulations. This is just like a tiny demonstration of like my file name before Signac. So here you can see that this is actually quite easy because I just put two parameters there. So you have like n, and then there's like stuff like I did squares, and then I did triangles, whatnot. Yeah, and so you can imagine that if I'm reading all of this, and then I have to be like, okay, I measure data, and then I need to use regular expressions to parse my file name, and that might not be correct all the time. And if I want to add something else later, and it's just really bad. Also, just by looking as is, like you have to keep thinking about like what is the file name you're reading. So there's just like a lot of unnecessary work you have to do. But another thing that is really important is like sharing data with other people. That this way you will never be able to share your data with other people, or other people will never want to read your data, and just it's really not good. And especially in this day and age that we really want to have data accessibility to other people. So it should be made as easy as possible for other people to read it. And what we do is like we take all this like parameters similar to like a JSON file, so you can read a text value based on like, and then give you a numerical value, and then Signac does a very smart trick to encode this into like a string of like string of hex code. So, and then it very smartly can map the string of hex code to your metadata JSON file. So now this is like in one folder, but it's exactly the same format in every folder. And then I will always know that I have these 3 lost files. If I want to read them, I never need to change the name based on their metadata anymore. It's all the same. And here, that's like all your metadata here. So here, I can say like I have a system with 6 particles that I want to form an octahedra, and then a bunch of like random things. And this, yeah, so in this way that now you can do a very easy Python scripting to like go through all the data. Yeah, and you can also, there's a thing called drop.document. So if there's other metadata you want to add afterwards, so you can always just like keep adding to it, and it will be fine.